All right, guys, let's knock out this last review before fall break. Number one, A and B says determine whether f is even, odd, or neither. One thing I'm looking at on part A is I'm not expecting it to be even because there's an odd exponent in it. But the way you can tell if it's even, if it's symmetric to the y-axis, is if you plug in negative x for the x's and you get the same thing you started with. So I'm going to plug that in to both x's. It's like that. I should just have that a y. Y over there, the negative to an odd exponent keeps it negative, so that's going to be negative 2x to the fifth. That's going to be a negative 3x squared because that changes it back to positive. Plus 2. Now I'm asking myself, is that right there the exact same thing I started with? Nope. Is it the opposite of what I started with? Nope. So it's not even. To check odd, you plug in a negative y and a negative x. Now, plug in negative y, you just change the y to negative. I've already plugged in negative x, and that right-hand side right there is what I got when I plugged in a negative x. So I'm going to check this out. I'm going to check this one this time. I'm going to refer back up here and see, is it exactly the same? Nope. Is it the exact opposite? Nope. So that means there's neither odd nor even, either one. Part B, same deal. Now, one thing I'm noticing about this one is the exponents are even, which is a hint. It could be even, not necessarily, but it could be. So put those x's in, and when I do that, this is what I get. Let's see, that square is going to change. It's going to get rid of that negative sign, so just get this. This square on the bottom is also going to get rid of the negative sign, so I get that, which is the exact same thing I started with, which means it's even. Don't even have to check for odd. It can't be odd and even at the same time. That's impossible. Number two, looking at graphs and doing the same kind of thing. Remember, even as if it's symmetric over on the y, but with respect to the y-axis, this is not. You can't fold that over the y-axis and get the same thing. Odd as if it's symmetric at the origin, which means if you turn it upside down, it's exactly the same, which that one does. That's an odd. Number five, part B. I don't know why I said number five. This one's a weird one. When I first look at it, it's definitely not even because it's not reflected across the x. If we were to turn it upside down, it would look like this, and what it would be odd. The only thing that messes it up is this bottom one down here, and I don't know if this is on purpose, but it's got a filled in circle and that one's got an empty circle, so that's a neither, and it's only because of that crazy empty circle. Number three, write an equation. They're going to give you like this one, absolute value, like a parent graph, and they want you to tell. They're going to use some transformation to do, and I want you to write it, the new function. So this one says 3 units to the right. Remember the gesture, inside, opposite of what you think, left and right. So I'm going to put minus 3 because it's opposite of what you think. Down 2, that's outside, minus 2. That's all there is to it. This one, the same kind of problem, says reflect across the x-axis. Reflect across the x means there's a negative in the front. A horizontal stretch by 2 means there's a 2 multiplied inside. Actually, not a 2. It should be 1/2 because remember, it's stretched by the reciprocal. So it should be 1/2 x inside, then a plus 3 outside. That's the negative right there. All right, number 5. One thing I forgot to write in the directions about 5 is to put your domain. So I will be doing that also. And the good thing about the domain is the domain of the f is all reals. The domain of that should be g. G of x is all reals. So when I combine them almost every time, it's going to be all reals. So f plus g, I'm just going to add those together. When I add f and g together, I'm not showing the work, but the x squared would cancel and it would leave me 1 plus 3, which is 4. And the domain for that is all reals. Part B, I'm going to subtract this time. X squared minus negative x squared is 2x squared. 1 minus 3 is negative 2. Also all reals. F times g, I'm doing FOIL here. First, I'm getting 3x squared. Outer, I'm going negative x to the fourth. Inner, I'm getting 3. And last, I'm getting negative x squared. So I end up with this, negative x to the fourth plus 2x squared plus 3. And again, no fractions, no radicals, it's all reals. F over g, I put x squared plus 1 over 3 minus x squared. Domain, you can't make the bottom cannot be 0. Remember, denominator can never be 0. So I'm going to come over to the side somewhere, and I'm going to say, okay, 3 minus x squared equals 0. What would make that equal 0? Well, if I move the x squared over like that, take the square root, that's what x cannot be. So I'm going to just say this. The domain is all x such that x cannot equal plus or minus square root of 3. And there you go. Part E says f of g of x. So I'm going to take g of x and plug it into f, which is going to look like, I shouldn't have done that. It's going to look like 3 minus x squared plus 1. So I'm going to do square multiply double square, square multiply together double, square. And I'm going to end up with an x to the fourth minus 6x squared plus 10. Now it's going to ask you for domain. The way you do domain of those types is you do the domain of the second one, which is all reals, and then compare it with your answer, which is also all reals. So that domain is all reals. And the last one is g of f of x. So now I'm going to take function f and plug it into function g. So I get 3 minus x squared plus 1 squared. Now, that might be careful with that minus sign is going to go for everything that I square. So I'm going to do square, multiply together, double, square, and then distribute that negative sign, which will give me negative x to the fourth minus 2x squared. And if I take that 3 and do 3 minus 1, that gives me 2. So there's that one, and it's also all reals. So everything was all reals except for the division. Not bad. Use inverse function property to show that f of x and those are inverses. Now, to prove that they're inverses, what you must do is you must show that f of g of x is x and g of f of x is x. So I'm going to start out by doing f of g and see what I get. If I do f of g, I'm going to get 2 times x plus 5 over 2 minus 5, and just work that out. First of all, the 2's cancel. That leaves me x plus 5 minus 5, which is x, which is what I wanted. G of f, just go backwards. I'd go 2x minus 5 plus 5 over 2. Right there, the 5's cancel. That leaves me 2x over 2. The 2's cancel. X, which is what I hold, both x's. Number 7, enable, let's say find the inverses, all right? Inverses, remember, x and y switch and get the y by itself. So I'm going to put the x over here, the y minus 2. This is a tough one because there's 2 y's, right? And watch the strategy here. I'm going to cross multiply. That's really x over 1. So I get xy plus 2x when I go this way. When I go the other way, I'm getting y minus 2. Then I got to get the y's together. So what I'm going to do is I'm going to switch those 2 terms right there. I'm going to put the y where the 2x was and put the 2x on the other side with the 2. And here's the trick to the whole thing. To get that y isolated, I'm going to come up here. I'm going to factor it out of those 2 terms, which gives me this. All right, so to finish up, to get the y isolated, I'm going to divide both sides by the x minus 1. So I get negative 2x minus 2 over x minus 1. Remember, we want to write our function notation like that. There's your inverse. That's a good one right there. Make sure you study that. Number 8, believe it or not, isn't as bad as number 7. Start out the same way. Switch your x's and your y's. So you get this. You got to get that y isolated. So I'm going to take the cube root of both sides. I'm going to cube root of x is y minus 4. So to finish up, I'm just going to move the 4 over. So I get inverse of f is the cube root of x plus 4. All right, not too bad. Number 9, simplify, which means add all those fractions together, which means you need the LCD. The LCD on this one is going to be x and x minus 2 squared. Remember, if there's an exponent, 2 factors the same, you got to use the biggest exponent. So ask yourself, what's that first term missing? It needs an x minus 2 squared. That's what I'm multiplying the top by. The second term needs an x and an x minus 2. The 1, you can put a 1 if you want to. You don't have to put the 1 there. And the last term is just missing the x, so I'm going to put a 3x. Now, good night. Do not start canceling stuff yet. You got to multiply all that stuff on the top out. So I'm about to go square, multiply double, square. Here, distribute the x. And I got the 3x at the end, all over x and x minus 2 squared. I'll probably leave you enough room for this one. Distribute the 2, 2x squared minus 8x plus 8. X squared, just plus 1x. And I have an x and an x minus 2 squared. Let's see what I can add together here. I got a 3x squared minus 7x and a plus 8 over x and x minus 2 squared. Now, I do need to check. That's probably the answer. I do need to check and make sure nothing factors that I can cancel. So I'm going to do slide divide slide real quick. I'm going to just attempt it. If I slide that 3, it gives me 24. There are no factors of 24 that will give me 7. So you know what? That's it. That's all you got to do. Number 10, solve that thing. Oh my goodness. So you need to isolate the radical before you start squaring stuff. So I'm moving the 1 over, which leaves me this. 5 minus x inside over here. Over here I have x minus 3. And I'm going to square both sides. Now be careful. When you square both sides, you literally square the side. So the left-hand side, the radical's gone. The right-hand side, square. Multiply, double, square. And now moving everything over. All right, moving that x over gives me negative 5x. I'm moving the 5 over, which gives me positive 4. Going to factor x minus 4, x minus 1. Gives me 2 answers, 4 and 1. Remember, you got to check. You must check. Now, one thing about the 1, I know 1 can't work because it makes that side negative, so that's out of here. Try the 4. Yep, 4 works great. Love it. Number 11, rationalize. Okay, because this is a cube root in my denominator, I need to have 3 x's inside before I can take the radical away. So I'm going to multiply the top and the bottom by the cube root of x squared. And the reason I'm doing that, the reason I picked x squared is because in my denominator now I have cube root of x cubed. And guys, the cube root of x cubed is just x. I just pull the x out there, and I'm fine with that on the top. No big deal. Let me show you one more way you might want to go here. You could always rewrite this x to the 1/3. And think about your denominator. You need just x to the first power. So what do you add to 1/3 to get 1? Answer is 2/3. And think about what 2/3 mean. 2/3, first of all, the bottom. When I multiply the bottom, use that the exponents. 1/3 and 2/3 is 1. On the top, remember, bottom is the root, top is the power. Look at that, look at that. Either way you want to go is good. Number 12, determine whether y divides a function of x. So to do this one, you need to isolate the y. So I'm going to say y to the 4th equals 2x plus 16. And because it's a fourth power, you got to take the 4th root. And when you take the 4th root in an equation, this goes in front. That's a big deal because no matter what I put in for x, because there's a plus or minus sign in the front, I'm going to get 2 answers for y. It means it's not a function because every x can only have 1 y, and in this case, every x has 2 y's. And the last one, the piecewise function. Right here, let's take the -2, plug it in. -2 plus 6 is 4, so I'm going to go to -2, 4 right there. Empty circle because there's no equal sign. And because it's going left, I'm going to go 1 to the left and plug in -3. -3 plus 6 is 3, so I'm going to go -3, 3. There's my second point. That's a line. It takes 2 points to make a line. It's going just like that. There's the first piece. Second piece, I'm going to take -2, plug it in there. -2 squared is 4. Right back up there. Now, I know this is a parabola because it's x squared. X squared is a parabola. So plug the -1 in there. I'm going to keep going to the right. -1 squared is 1. 0, so I'll plug the -1 now. Plugging in 0, 0 squared is 0. +1, +1 squared is 1. I'm starting to see the parabola. Plug in 2, +2 squared is 4. I definitely see the parabola now. So it's going to do this. And it is going to go forever because it does. All right, hope that helps. Finish strong. Last test of the quarter. All break starting. You're good. I'll see you tomorrow.